Hello and welcome back, everyone. Today we're going to talk about linear quadratic systems. So, what do I mean by linear quadratic systems? I mean when we have a quadratic, so some sort of parabola, and a line, and we want to know where do they intersect, if at all. And when it comes to linear quadratic systems, there are three possibilities. Possibility one is we might have 2 points of intersection, like this example, right? Or maybe we have 1 point of intersection, like here. Now keep in mind, when we have only 1 point of intersection, that point of intersection is going to be the vertex. And we might have no points of intersection. Here we have a line, and in this last example here, we have a line, we have a parabola, and they never intersect at all. And even if we were to extend that line and extend that parabola, they never would intersect. And so those are our three possibilities for linear quadratic systems. So let's talk about how we can actually go about solving these linear quadratic systems. Example 1 asks, find the point of intersection between the quadratic y equals x squared minus 10x plus 14 and the line y equals 7x minus 16. So if we want to find the point of intersection, I'm going to equate these two. I want to make them equal. We know that on one hand, y equals x squared minus 10x plus 14, and on the other hand, y equals 7x minus 16. So I'm just going to equate the two. I'm going to say x squared minus 10x plus 14 equals 7x minus 16. And then I'm going to solve for x. So let's do that. Let's subtract 7x from both sides. So x squared minus 17x, and then add 16 to both sides, and we get an equation like this. Now there's two possible things we could do from here. We could either use the quadratic formula to solve this, which would be my preference generally, or we could find two numbers that multiply to 30 and add up to negative 17. Now actually I already have those two numbers in my head, so I will factor in this case. Two numbers that multiply to 30 and add up to negative 17 are negative 15 and negative 2. So let's just do that. X minus 15 and x minus 2. Now, if you are confused how I got this, I do have a video about factoring quadratics and solving by factoring, and I suggest you go to that in that case. Okay, but with that said, now we have the answers for x. We know that x is equal to 2, or x is equal to 15. So already from this, we know that there's two solutions, that this parabola and this line intersect 2 times definitely. Now, the next thing we need to do is we need to find the y values, right? These are just the x coordinates of where the parabola and the line intersect. It doesn't account for the y coordinates, and they didn't just ask for the x coordinates. They said, what are the points of intersection? So to do that, we need to plug both these x values individually into one of the equations above. I'm going to choose a line because it's easier. However, you will still get the same answer should you choose the parabola. Or you could even plug them into both just to make sure you got the right answer. But I'm just going to plug it into the line. So I'm going to sub x equals 2 into the line, which is y equals 7x minus 16. So that's 7 times 2 minus 16, which is 14 minus 16, which is negative 2. So therefore, one of the points is 2, negative 2, right? We have x equals 2, y equals negative 2. Then I will do the same thing for x equals 15. So that's going to be equal to 7 times 15 minus 16. What's 15 times 7? Maybe it's 105, something like that. Let me just check that though. It is 105. Okay, 105 minus 16 is going to be 89. Okay, so therefore we have another point that is 15 for x and 89 for y. So therefore, the points of intersection, it asked to find the point. There were 2 points in the end of the day here, so we'll just say the points. Therefore, the points of intersection are 2, -2, and 1589, like that. And there's our answer. All right, so let's try a few more examples like this. I have a few more examples here, or at least example 2. A bird perched on a cliff, h equals 0, swoops down towards the ground to search for something to eat. The height of the bird is given by the equation h is equal to 2x squared minus 10x plus 6, where x is the time in seconds and h is the height in meters. A bug jumps from the ground at the same time with a height that is represented by h equals 2x minus 12. Do the bird and the bug meet each other? If so, after how long? So what they're essentially asking is, do they ever meet? Are their heights the same ever? Or, are the seconds and the heights the same ever, right? Because maybe they both get to the same height, but at different times. We want to know what are the points of intersection between where the bird is at and where the bug is at. And the bird seems to move in a quadratic formation, where the bug seems to just move in a line, in a linear formation. So same method here. We're going to find out when, if at all, is it true that 2x squared minus 10x plus 6 is equal to 2x minus 12? So first I'm going to get everything over to one side and get 2x squared minus 12x plus 18 equals to 0. Then I'm going to factor out my 2. And then here, actually, there is a way to just factor this pretty easily. This is actually a perfect square, so we can factor it this way. Again, if you're unfamiliar with factoring, if going from this step to this step seemed like a bit of a leap, no worries, but definitely do go take a look at the previous content. Then the next step here is to say, okay, well, what's the answer? The answer would be x equals to 3 would be our solution here at this point. Now, in this case, there's only one solution, right? Because it ended up being perfect square, so just one solution instead of 2. And then, of course, we need to sub x equals 3 into h equals 2x minus 12. So h equals 2x minus 12 means that h equals 2 times 3 minus 12, which means that h is equal to negative 6. Now, does that make sense? H is equal to negative 6. Did I make a mistake here? Let's see. No, this looks good. Okay. So perhaps they go underground. Okay. So perhaps they meet each other after 3 seconds when they're at a height of negative 6 relative to where they were before in this case. So let's write that into words. That therefore, the bird and the bug do meet after 3 seconds at height negative 6 meters. Now, normally I would say height negative 6 meters, that doesn't make sense, but upon relooking at the question, the bird perched on the cliff, the top of the cliff is h equals 0, so that's the height. It swoops down, right? So it's going below 0 where we put our 0. So in this case, h being negative actually makes sense because, of course, the bird and the bug, if they were to meet, are going to meet below that, below h equals 0, below the top of the cliff. So this does make sense. However, if you wanted even more confirmation that this is the correct answer, we could also sub the x equals 3 into the other equation. So we could get 2 times 3 squared minus 10 times 3 plus 6 and verify that that's also negative 6. So this is 18 minus 30 plus 6, which is also -6. Okay, so this is just a double check. This isn't really a necessary step. This is just like an extra kind of double check of, oh, our answer was kind of strange. Maybe we should check if that answer truly does get the same y value for both. Because if it does get the same y value, or in this case, h value for the height for both, then it makes sense. It's going to work. But if you get two different h values, then there's a problem, right? Because the whole point was to say, what is a value, what's a point that these two equations that they have in common. And if when you plug in the same x value you get different y's, that means it's not the same point for both equations. It's two separate points for each equation. So that's an important thing to do. Good. Or if you wanted to be even more descriptive with the conclusion sentence, you could say the bird and the bug meet after 3 seconds at a height that is 6 meters below the top of the cliff, for example. All right, well, that is everything for the linear quadratic systems. Yeah, because this we did last time. Let's head back over here. I do have some suggested practice exercises for anyone who is interested. So, for linear quadratic systems, these are the suggested practice exercises, and these are from the Nelson 11 textbook, which is linked in the description below. But that's it for today. Have a great day, everyone, and we will see you for Unit 2. Unit 2 is often, a lot of classes do it as Unit 1. I think it makes more sense as Unit 2, though, personally. But it's all about functions, function notation, introduction to parent functions, all sorts of new things that you probably didn't learn in grade 10. All right, well, that said, good work today, everyone. I will see you back for the second unit. Bye, everyone.